Hi all, this is Dr. Shanthi, Professor, EC Department, RMK College of Engineering and Technology. In this presentation, we are going to study about the introduction of the subject Digital System Design. The subject code for Digital System Design is 24 EC 403. Why should we study Digital System Design? In today's world, whatever devices, whatever day-to-day equipments or components, whatever you're using are fully digital. The best example is your laptop and your mobile phone, right? Everything is digital, right? Once we are thorough with the digital system design, we can understand the back work that is taking place. For example, when you open your laptop, you can see the various components that are there within the laptop. Now, if we are confident enough about how the various components or how the various logic is working, then we can understand the under the hood of computers, meaning that we can become a better programmer. We can do programming or we can go in for more integration when we are aware of all the hardware resources and the issues in the hardware. Now, when I say the hardware here in digital system design, it is going to be the logic gates, which are the basic building blocks. All the electronic devices, whatever we are using nowadays, is fully digital. VLSI design is playing a major role wherein all the electronic devices are shrinking. The size is shrinking day by day with more processing capability. Now, digital system design is marching towards better devices so that we can have better sound recorders, better cameras, better cars, better cell phones, and better medical devices. And all with the latest technology in digital system design, we are going to have better video games, PDAs, and we are marching towards embedded systems where thousands of new devices are being put in a small area. So we are marching towards a new era of digital system design. Now, digital system design is nothing but an interconnection of various digital modules. For example, if I have a half adder or a full adder, we will have interconnection of many logic gates. In the same way, a big system, for example, in order to obtain a laptop, you will have many subsystems or you will have many digital modules. So all those have to be interconnected. It is designed to manipulate logical information or physical quantities which are represented in digital form. Right? When I say digital form, in the binary form in terms of zeros and ones, and the best examples are your digital computers, digital cameras. All the communication within the system are carried out in digital manner, meaning that all the communication is going to take place in terms of zeros and ones. Now, what is digital? Right now, when you look into you can see digital cameras, digital TV, digital watch, digital radio. All that what you see is it gives all the things in countable form. Say for example, a scene which is in analog form, we are going to see it in digital form, right? Now, when I say what is digital or why digital is, you can have countable form. When you have it everything in countable form, it makes as easy to manage. Easy management makes more useful and versatile. And what is the digit that is used? When I say digital, what digit? You can have either decimal, you can have binary, octal, hexadecimal. You will study various number systems. Now, electronic circuits are majorly classified into two, analog circuits and digital circuits. And this classification is based on how voltage and current vary during the operation. Okay, now when you look into it, the first picture shows the analog signal, which means that when I take an analog signal, say for example, the first point given here is infinite possible values. What do you mean by infinite possible values is, say for example, look at this voltage. when you can represent this voltage at each and every instant of time based on how you are going to take the reading. For example, I can represent the value from 1 to 2 as 1.01, 1.02, 1.03, 1.04. So you can have infinite number of values or based on the scaling whatever you take, right? So this is going to be analog signal, right? Now, whereas in the case of digital signal, you're going to have finite possible values. For the best example is you take your laptop. Now, when I press the number 2, right? When I press it, what will be displayed? 2 will be displayed on the screen, right? If I don't press it, it will not be displayed. So either on or off, either high or low, right? Now in this case, now when you look into your keyboard, when I press a key, a particular value will be displayed on your screen. So you have countable values assigned to each key in your keyboard, right? So for example, see here, so you have 1, 2, 3, 4, which means that for 1 you will have a voltage level of 1 assigned. For 2 you will have a voltage level of 2 assigned. For 3 you will have 3. You will have 4, right? So in this case you will have only finite possible values, whereas in the case of analog signal you will have infinite possible values. The same thing explained in a better way. Now when I see look into the picture here, the picture here is an analog thermometer, which means that here you have a scale or a pointer to show the reading, right? See here, you have a pointer. Say for example, the pointer is showing a value between 60 and 80, right? Now you can have infinite possible values, right? For example, you minus 10 to plus 10 can be divided as minus 10.1, minus 10.2, minus 10.3, right? In the same way, you can based on the scaling you will have values, right? Say for example, minus 10 to plus 10 means, say from to the right of 0 I can have 0 0.1, 0 0.2, 0 0.3, 0 0.4, right? So or I can even divide it as 0 0.01, 0 0.202. So I'll have infinite possible values, and voltage and currents vary continuously over a specified range, right? Signals have numerical significance. Say for example, an audio amplifier can vary, the output can vary between minus 10 and plus 10 at any given instant. Examples are signal generators, RF transmitters, receivers, power supplies, all that, right? And the best example shown here is an analog thermometer. In the case of digital circuits, voltage assume a finite number of values, which means that maximum there will be, you will assign two values, right? A high or a low. A high is 1 or low is 0. For example, when you have when you press the key, it is high. A signal will be shown as high. When if I don't press a key, it is a low, right? Each level is actually a small range of band of voltages, not a single exact value, right? In the last figure, if you must have noted, for 1 it was voltage 1, for 2 it is voltage 2, which means that from 1 to 2, that voltage range is assigned to 2. In the same way, for every value will have a small range of voltage. Okay, right? Now example, additional circuits are also called as switching circuits, right? Voltage switches instantaneously between levels, and all the logic circuits operation follow defined logic rules. Now the diagram shown here is a logic, that is digital thermometer, where the value is displayed here, right? Now you can see the value displayed here, right? And the values will be either high or low as shown in the diagram. And applications of digital systems, you have computation and data processing, where it is done in computers, embedded systems, control systems, communication systems, measurement systems. And numerical data representation, in analog representation, information is in continuous form, which means that, for example, if I take voltage, the voltage varies continuously with respect to time. Examples are going to be audio and temperature. Whereas in the same way, in the case of digital representation, information is going to be in discrete form, which means that it is going to make use of binary numbers 0 and 1. Now, advantage of digital systems. The main advantage is Now look at this signal, right? Now we have an analog signal. Say for example, I am transmitting 3 volts from the transmitter side. On the receiver side, what happens is I am getting only 2.5 volts. Now look at this diagram. Now my signal has been attenuated, or signal has been lost. So what happens is the received quality, the signal that has been received at the receiver may not convey the same information as the original signal at the transmitter side. So what happens here is there is an attenuation, right? Or the quality, what is say for example, if it's audio, the audio quality will be lost on the receiver side. But when I go in for digitization, what I do is I have converted the original signal in form of zeros and ones, right? So in each time slot, what will I do? I just check for whether a signal is present or a signal is absent. Now look at this diagram. On the transmitter side, this is the diagram, and on the receiver side, this is the diagram. Now I have a small change in the shape of the signal what I have got in the receiver side, but still the signal quality at the receiver side is not lost. Why? Because what in each time slot, what you will look for, you look for only whether the signal is present or signal is absent. You will have a threshold level. Say for example, if the signal is greater than 2.5 volts, it is 1. If the signal is lesser than 2.5 volts, say it is 0. So the threshold will vary from application to application. So in the case of when I go in for digitization, there will be less noise. The system will not be affected by noise, and the reception quality will be the same as that of the sender side, right? So that is the biggest advantage of going in for digital, where we just look for presence or absence of the signal. These are the advantages of digital systems. The main advantage is it is easier to design, because adding modules is very easy. Putting more hardware and that is programming is very easy. So when compared with analog circuits, digital circuits are easier to design. Information storage is also easy. The best example is your USB, where memories are used for storage. Higher accuracy. So why? Because higher accuracy, because we just looking for presence or absence of a signal, so less affected by noise. So that is the next point given. Less noise, more versatile, which means that more operations can be added just by changing the program. We didn't change even the hardware, and compact size. So these are the advantages of digital systems.